The first generation of cloud was based on virtual machines, which had a very simple pricing model, right? It was a fixed dollars per hour. You decided when it started, and you decided when it stopped. And Lambda, and everything I'm going to say today applies to Azure Functions. And Google, I think Google calls it Cloud Functions. They're still in beta, so they're still TBD. So Lambda has a very different economic model. And does anyone need a one-sentence description of Lambda? Yeah. Yes. So a Lambda, and by the way, Lambda is used as a keyword in many different programming languages, going back to functional programming languages. A Lambda is a method or function in a particular programming language with a particular interface that is called on a specified event. So the interface is the same for Amazon and Microsoft. There's two arguments. First argument is an event object. Second argument is a context object. And the kind of events that you can call a Lambda on are a message arrives at an API, call that Lambda. The table or record changes in some persistent store, call that Lambda. Somebody put a record on a stream or a queue, call that Lambda. So it's functions being called on events, and they're passed an event object. The event object is specific to the event type. And Lambdas are priced differently. So at the end of the month, you will get a cost, you get a bill, and that bill will be the sum of two things. It'll be how much total time all of your Lambdas took to execute, plus how many Lambdas you called. And the time to execute, dollars per second, scales linearly with memory, which is just what VMs do, by the way. They work exactly the same way. And the dollars per invocation of a Lambda is actually independent of memory size. The cost for execution is this funky number here. And VMs are priced in dollars per hour or dollars per second. Lambdas have these funky little units here, dollars per gigabyte second. And as it turns out, I'm going to show you next, that's actually the same way, the same pricing model as virtual machines. You get 400,000 free gigabyte seconds a month. And they measure it in 100 millisecond granularity. For invocation costs, it's 20 cents per 1 million invocations. You get 1 million free every month. Azure is identical, with one exception. When you configure or define a Lambda, you specify its maximum memory that it's allowed to use. Amazon goes from 128 meg up to 3 gig in 64 meg increments. And you're charged by that number, whatever that number is. Azure is a little more flexible. You configure a maximum memory size at the time you create the Lambda, but they actually charge you for actual memory usage. They sample your memory, I think, every second. And they average it over the lifetime of your Lambda, and they charge you for that. So I predict Amazon will probably go to a more dynamic model as well. So as I said, the units of Lambda cost may seem a little funky to you, right? It's dollars per gigabyte second. VMs are actually priced the same way. They kind of hide it because they'll give you a whole table. You'll get like an M4 and it'll say 4 gig, an 8 gig, 16 gig, 32 gig. And you'll see the cost, the dollars per hour for that M4 instance scales linearly with memory. So given that, you can actually express the cost of virtual machines in the same units, dollars per gigabyte second. And when you do that, you will get this. So M4 and M5 are general purpose instances, and I picked them because Amazon says in their documentation, the CPU power allocated to a Lambda scales linearly with memory just like a general purpose instance. So an M4 is a very common general purpose instance. So M4 is whatever that is, 4.0, 10 to the minus 6 dollars per gigabyte second, if you were to look at all the memory ranges available for an M4. Lambda is that other number I had on the earlier slide, 1.6 times 10 to the minus 5. It's quite a bit larger. The important point to note here, two things. One is this is just the cost for the compute of Lambda, right? In addition to this, for Lambda, you must pay for activation. And this doesn't here, this graph here does not include the free tier. So if you're not using it very much, obviously that comes down. But the takeaway here is they're actually pricing the compute cost for Lambdas. The base price is quite a bit higher than, say, a virtual machine. And the reason they did that and I got this from the mouth of the people at Amazon who created Lambda, is that, well, I'll show you in a minute. Easier to see on the next slide, I think. So with a virtual machine, you have, you have threads. Threads may be either active or suspended. You have any number of them that you want, and you pay for wall clock time. You pay if there's nothing going on, you pay if there's 1,000 threads, if there's one thread. If it's node, you pay if there's one closure running or a billion closures running, right? It's a fixed cost. With Lambda, if you were to have the same kind of implementation, right? So the events are coming in the same way. The world doesn't care whether it's a virtual machine or a Lambda. So the arrival time of events is the same. You pay for every time you activate it, so every event. In this case, let's say this is a web server. Every message that shows up at an API, you pay whatever the 20 cents per million. And you pay only for the time it takes to actually process the message. So the difference here is that the marginal cost of more work for a virtual machine is zero. You're paying for wall clock time whether you're doing anything or not. For Lambda, the marginal cost is some fixed number, right? Whatever the dollars per gigabyte second, depending upon your memory size. So what that means is there's going to be some level of activity above which Lambda will be more expensive than a virtual machine. Oh, and so I was going to say something else here about this slide. Why did they price it so much higher? Well, think about it from the perspective of the cloud vendor. They just wrote $1 billion check to buy hundreds of thousands of servers and stick them in a nice, cooled, humidity-controlled data center. That's sitting on their balance sheet, that $1 billion. They have to monetize that. And they monetize it by selling time on the servers. With a virtual machine, I'm going to charge you X dollars an hour, no matter what you're doing. I don't care. It's not my problem, right? You light up a VM, I'm charging you whether you're doing anything or not. With a Lambda, that's not true. I'm only going to make money when you're doing something. So if you look at this, this diagram here, the cloud vendor is making no money in the white part. They're only making money in the green part. So they were concerned about, hey, I'm not sure I'm going to this may hit my revenue. So, and Lambda is a very new model. It's new for the cloud. It's obviously not new in functional programming. And so I think what they did here is they gave themselves some buffer, some economic buffer to make sure that their revenue wasn't going to drop. So the other point here, this is just a cost statement, right? Performance is a different ballgame. I'm not doing performance in this slide, but I have another slide in another presentation just like this, but the point is Lambda performance will be almost flat. Every Lambda gets its own dedicated chunk of memory. All the threads or closures in a virtual machine compete for a common pool of memory, right? So at some point, performance goes asymptotic. So this graph, let me explain it. So the X and Y axes are the activity factors for a Lambda. As I said, Lambda cost is two things. How much time, that's the X-axis, and how many times you call it, that's the Y-axis. Virtual machine cost is constant over this space. Oops. Right, it doesn't care, it's flat. So imagine that there's another Z-axis coming out of the screen. The virtual machine cost is a flat plane over this space. It doesn't care how active it is. But the Lambda cost is not a flat plane, it's a curved plane. So at the origin, Lambda cost is zero. You're not doing anything, you're not getting charged anything. You're still paying 20 cents an hour for the virtual machine. It's a flat plane. At the upper right corner, the Lambda cost is the maximum. So it curves from 0 up to the peak in the upper right corner. So there's two planes here. There's a flat plane, which is the virtual machine cost. There's a curved plane, which is at 0 at the origin and highest in the upper right. And at some point, those two planes cross. And these lines are where those two planes cross, right? These lines are the activity levels of a Lambda that will equal the cost of, well, whatever I have here, these various M4s that you see here. And the different lines are just different memory sizes. And you can see the memory size doesn't make too much of a difference. So toward the origin, the Lambda is going to be cheaper. And in the upper right corner, the virtual machine will be cheaper. So as I said earlier, there is some activity level at which using a VM will be cheaper. Now this makes no statement about performance, right? So Lambda performance tends to be very linear, right? Because every Lambda that gets born gets its own CPU and its own memory. And every thread or closure, if you're using Node, we know Node uses closures, right? Every thread or closure in a VM is all competing for the constant pool. So memory performance is much more asymptotic. So Microsoft was second to market with what they call Azure Functions. And they have a pricing model identical to Amazon. I think what they did, they said, well, Amazon's already there. People are buying it at that price. I'm just going to copy it, right? Because Amazon had the same problem. Microsoft had the same problem Amazon does. They wrote $1 billion check for all of their servers. They need to monetize it. As I said earlier, Microsoft has a slight advantage because they're charging you for actual memory use rather than just the fixed. But Lambda, as that earlier graph, Lambda was about 5x more expensive on a time memory basis than a VM. It isn't really, they're charging that much more, but it isn't that much more expensive to the vendor. It's a little more expensive because, I don't want to go into it here, but the average power dissipation of a server is going to be higher because Lambdas only run when there's something to do. A VM is sitting there even when there's nothing to do. So Lambdas are only light when the CPU is going to execute. But I think that there's a lot of headroom here for pricing to come down. And I'm hoping that once Google gets into the market, that they're going to underprice these guys and maybe start a little price war here. That's just my hope. So Lambda, I believe, as we know it today, is really is going to evolve. I think it's the first step in really a long evolutionary path. So I think there's some really interesting things to do. So one of the Achilles heels of Lambda is if you do a cold start, they have to build a container. You don't see the container. And they have to light it up on a virtual machine. And so you may actually see some of that latency if you're unlucky. And so one of the things that is interesting is, say, for these Lambdas, I want them to be warm all the time. I want the container pre-built, sitting there ready to go, so when the message arrives at the API, just light it up. And I'll do that for a fee. So right now, there's no such thing. Lambda it's just random chance. If you haven't, if an event has not arrived on a Lambda in more than about 4-ish minutes, this is Amazon numbers, you'll get a cold start. What that means is they'll have to build a container, light it on. There's containers under there, but you don't see them. They'll have to build a container, so you'll see that build time before your Lambda actually starts executing. If it arrives within about 4-ish minutes of the last event for that Lambda, it'll be a warm start because the container will be sitting there in memory. So, but that's just probabilistic, right? I think it's interesting to allow customers to say, hey, I want to pay a little more money to make sure this Lambda is always a warm start. Another interesting thing to do is Lambdas are stateless, so the typical pattern, and it's enforced stateless, you don't get the choice. When the Lambda dies, everything in memory is gone. So if you need it, you need to save it to a persistent store. So a typical pattern is when a Lambda lights up, it reads some persistent store, it does some math, and it writes a persistent store. So I think it's going to be interesting to say, I want a persistent Lambda where I don't have to redo a bunch of work every time this event happens. I want to keep some running, some, or whatever you have. So no rework. They can, the latest machines on Amazon, at least, they use NVMe. So kind of cool stuff. Dynamic pricing, I think it's interesting to look at spot Lambdas, where it's like, hey, I have some work to do. I'm not in a hurry, but if prices drop below X, why don't you launch these Lambdas for me? Because then it becomes economically interesting for me to do that. And that's it.
Great.
Thank you. Question?
Do we have any questions? There's one. Okay.
Do I need my slides to answer them?
I thought it's kind of interesting that actually with this new pricing model, in order to optimize for the lowest price, you have to do some pretty integral math, and you may have to change your application very significantly, rather than when you're in more familiar territory or you're working with a more familiar looking user where you can optimize it more easily because that's something we've done a number of times. So I think that this is a very interesting aspect that like I have a Lambda app, and for me to go and it's a pretty simple one, and I only use it like it's 1 hour per hour, right? and only have certain amount of time for it. So for me to go and optimize it, it's like I need to actually rethink about a number of things and potentially rewrite it, and I can see how that would be so much of a bigger problem if you're looking at it as a real application that a whole team had built. Right.
Yeah, and by the way, you can build a system by, you can mix VMs and Lambda, right? You don't have to have, it doesn't have to be just a VM only or Lambda only. So you can have your very, very high frequency activities on a VM, and then some lower frequency ones on Lambdas. That's one option. But everything I'm saying here about the pricing, I was not making a performance statement, because there's also a performance statement.
Yeah, right. So I think it's important to understand that it's an untrivial problem for a lot of people. Yeah. To actually take advantage of the pricing model.
Sounds like somebody should write some infrastructure to automate that.
Yeah. Okay, great. More questions? Yes.
Can you comment about the load balancing on Lambda? Is that like for VM is really handy so far, it's quite mature.
Right.
Like for the whole VM to bring it up when the traffic is high. But for Lambda, it's kind of like a black box for me.
So all of that is taken off of your hands, right? In a virtual machine world, you have to build the whole AMI, operating system, all the libraries, all the way up to the app. You have to worry about load balancing. You have to worry about when a message arrives, what API did it arrive on? Is it a get, a put, a post, or a delete? Blah, 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 blah. All of that's taken out of your hands with Lambda. You don't need load balancing. That's taken care of by Amazon or Microsoft's infrastructure. So you can run, if a million messages arrive all of a sudden, you can light a million copies of, well, they have a limit, but a million copies of the same Lambda, they'll just go.
So what was the monitoring mechanism behind it? So for VM, I can actually see the traffic goes up, but for Lambda, we just say...
Well, they have a nice, cool new service called X-Ray, and it's basically a path tracing performance or not. So they'll tell you how many times each Lambda was called. I think they tell you, the histogram of the runtime of each Lambda, that kind of thing. So basically, software has always been modular. Lambda is just another way to modularize software, and it's a graph, right? It's an event-driven graph.
I would say that part of what you're paying for in that. I would say that part of what you're paying for in that price difference is that you're running operations from Amazon at that point, and that's an important cost because doing that internally may cost you more.
Yeah, that's a good point, right? You're not paying for load balancing anymore. You're not paying for all the routing code that you have to do today. You specify routing now, in a config file to Amazon.
Application software, they're focused on that code, not operations.
Exactly.
And that's valuable.
Yeah. So now, like somebody was saying, you just focus on the business logic. You don't worry about any code that routes.
I mean, the other thing you're not paying for is like the sysadmin overhead of patching operating systems and runtimes.
Right.
And you have to hide these, right?
Yeah, so that's taken off of your hands. So obviously you'd be willing to pay a little bit for that. By the way, on Amazon, all Lambdas run on Linux. You don't get to pick the OS anymore. There is a container there, but you don't see it. It's not Docker. It uses C groups and namespace.
So I was just curious, just trying from what you said on the cost and why it's big, and so I'm wondering the pragmatism of maybe say having something like a Kubernetes cluster, EKS, whatever, using OpenFaaS on it to have, like I say, if you have high frequency lambdas on the scheduler using something like spot heads to just knock down the cost like dramatically.
Oh yeah.
It seems like real reality.
Oh yeah.
Roll your own fast solution on a randomly deployable chaotic spot scheduler.
Yeah.
Okay.
I think there's an opportunity for some economic arbitrage here, right?